So in part B, we're told the student performs the second experiment is identical to the first, except that the student grinds the chunks into powder before combining the powder with water. We're firstly asked what happens to the surface area of the reactants when we're grinding them into this powder, and well, logically, surface area increases. So we can obviously imagine if we have like a chunk of some object, if we make it into if we make it into a lot of small pieces, all of those small pieces will in total have a larger surface area than the whole chunk as one. Then in part 2, we're told the rate determining step for the overall reaction is the dissolving of the solids. Would the time required for dissolving the solids be longer than, shorter than, or the same? And what's going to be shorter? And the reason for that is because, again, surface area is larger. And if we have a larger surface area, that means that collisions between water particles and the surface particles can happen more often. So collisions are more frequent. And therefore our rate will increase, as more successful collisions can happen per unit time, and therefore it will go ahead more quickly. And in part 3, we're told when the reaction is complete, will the volume of CO2 be the same or not? And well, it's going to be the same. And the reason for that is because we still have the same amount of reactants. So we didn't change how much we have, we just changed in what form we are in, but overall the reaction will still proceed for the same length. So we still have same amount of reactants. So we cannot possibly be making more products just by making them into smaller pieces, as the mass overall is still going to be the same. And of course, we're working under the same conditions as well.